Hello friends, welcome to my lecture on Laplace equation. This is first lecture on Laplace equation. We shall start with two-dimensional Laplace equation. Let us consider the two-dimensional case, del square u equal to 0. Del square is the Laplacian operator defined as del square equal to, in the two-dimensional case, del square over del x square plus del square over del y square. So, del square u is equal to del square u over del x square plus del square u over del y square. Del square u equal to 0 gives us this two-dimensional Laplace equation, and these two-dimensional Laplace equation occur say for example, in the case of two-dimensional heat equation. Two-dimensional heat equation is given by del u over del t plus equal to c square del square u over del x square and del square u over del y square. C square is the diffusivity of the material. Now, in the steady state case, the temperature u x by t no longer depends on time. So, the partial derivative of u with respect to t is 0, and therefore, this equation, this two-dimensional heat equation reduces to u x x plus u y y equal to 0, which is the well known Laplace equation in two dimensions. We will solve this two-dimensional Laplace equation by using the separation of variables method. U x t is a u x y is a function of x and y. So, we assume that u x y can be expressed as a function of x into a function of y. This is called as separation of variables method. Now, if u x y is assumed as product of a function of x and a product of a function and a function of y, then you find its partial derivative. Partial derivative of u with respect to x is dx by dx into y, and then d del square u by del x square is equal to d square x by dx square into y. Similarly, del square u by del y square will be equal to x times d square y over dy square, and now del square u plus over del x square plus del square u over del y square equal to 0 gives us y times del square u over del square d square x over dx square plus x times d square y over dy square. We can divide this equation by x into y and write it as 1 over x d square x over dx square plus 1 over y d square y over dy square equal to 0, or we can write it as 1 over x double dash. X double dash denotes the derivative of x with respect to x of second order, and similarly this is minus 1 over y double dash. Now, left hand side is a function of x only, because capital X is a function of x, its twice second order derivative will be a function of x divided by x. So, left hand side is a function of x, right hand side is a function of y. X and y are independent variables. This can happen only when they are equal to a constant. So, let us write it as some constant k. So, x double dash over x is equal to minus y double dash over y equal to some constant k. Now, these equations x double dash over x equal to k and y double dash over y equal to minus k, they give rise to two second order ordinary differential equations, d square x by dx square minus kx equal to 0 and d square y over dy square ky equal to 0. Now, k is an arbitrary constant here. So, there arise three cases, k equal to 0, k greater than 0 and k less than 0. Let us discuss these three cases one by one. So, in the first case, when k is equal to 0, k equal to 0 means d square x by dx square is equal to 0 and d square x by dy square equal to 0. So, when second derivative of x with respect to x is 0, it means x is a linear function. So, ax plus b, and similarly y is equal to cy plus d. So, we have xx equal to ax plus b, y equal to cy plus d. Now, in the case when k is greater than 0, we can write k as a square of some real number. So, k equal to mu square. So, when k equal to mu square, in this case we have d square x by dx square minus k square x equal to 0, and for y we have d square y over dy square plus k square y equal to 0. Now, this is second order linear differential equation. Its auxiliary equation is m square minus k square equal to 0. So, m equal to plus minus, this is k square, k is mu square. So, this is mu square. So, this is d square over dx square minus mu square into x equal to 0, and this is mu square into y equal to 0. So, m square minus mu square equal to 0 gives you m equal to plus minus mu, and therefore, this equation let me call it Roman 1, Roman 2. So, 1 gives us the solution as x equal to a e to the power mu x plus b e to the power minus mu x, because there are two real roots plus minus mu. In the other case, second case, we have m square plus mu square equal to 0. So, we get two complex roots m equal to plus minus I mu. So, we get y equal to a cos, sorry, c cos mu y plus d sin mu y. So, c cos mu y plus d sin mu y, and in the case of k less than 0, k can be written as minus mu square. Then we will have the equations d square x over dx square plus mu square x equal to 0, where the solution will be x equal to a cos mu x plus b sin mu x. With respect to y, we will have d square y over dy square minus mu square y equal to 0. So, we will get y equal to c e to the power mu y plus d e to the power minus mu y. And so, u x y will be product of x x and y y for the cases k equal to 0, k greater than 0, k less than 0. Now, which case will be suitable for our problem? This will depend on the given boundary conditions. So, let us see how we tackle for a given problem. So, this is the various possibilities. Now, let us look at an infinitely long uniform plate. It is bounded by two parallel edges. These are two parallel edges, and at an end and an end at right angles to them. This angle is at right angle to them. This end is maintained at a temperature u naught. The temperature is u naught here, and at all points and other edges at temperature 0. So, here the temperature is 0. Here is the temperature 0. We have to find the temperature at any point of the plate in the steady state. So, we have to solve this equation u x x plus u y y equal to 0. The boundary conditions are, when on this x y axis x is equal to 0. So, u 0 y is equal to 0 for all y, and on the this axis this is x equal to pi. Okay. So, we have u pi y equal to 0 for all y, okay, and for all y greater than 0, and u here y is equal to 0. So, u x by u x 0 is equal to u naught. Okay. So, we are given, and then what happens is that when y goes to infinity, okay, u goes to 0. So, limit u x by y goes to infinity is equal to 0. Okay. Now, so these are the boundary conditions. Let us solve the given equation u x x. So, we assume that u x y equal to x x into y y. So, we get the equation. So, we get the solutions case k equal to 0. Case k equal to 0, the solution is u x y equal to a x plus b into c y plus d. Okay, a x plus b into c y plus d. Now, what happens when you take x equal to 0? Let us apply the boundary conditions. So, u 0 y is equal to this is small x, and this is small y. Okay. So, x equal to 0 means b times c y plus d. This is equal to 0, okay, when x is equal to 0. Now, this means that either b equal to 0 or c equal to d equal to 0. If c is equal to d equal to 0, okay, then y will be equal to 0, then c y plus d will be equal to 0. So, then uxy will be 0 for all x and y. So, this is not possible. Okay. So, we take v equal to 0. Okay. So, we take b equal to 0 and then uxy becomes b times cy plus d. I can write it as bc is a new constant, I can write it as e by plus f. Okay. Now, we are given another condition. What we have is that u0 by equal to 0, u pi y equal to 0 and ux0 equal to u naught. Okay. So, what do we get? We will have ux by equal to 0 as by goes to infinity. Okay. See, as by goes to infinity, okay, as by goes to infinity, ux by goes to 0. So, e must be 0. Okay. As by goes to 0 infinity, u goes to 0. So, e has to be 0, otherwise the temperature will not remain finite. Okay. So, E is equal to 0 means uxy is equal to f. We have uxy equal to f. And we see that uxy equal to f is not possible because we are given that u pi y equal to 0. Okay. So, since u pi y equal to 0, okay, f must be 0. Okay. So, uxy has to be 0 and therefore, this case is not possible. Uxy equal to ax plus b into cy plus d. Let us take then k greater than 0. When k is greater than 0, we can take k to be equal to mu square and then the solution uxy is of the type, we have a e to the power mu x plus b e to the power minus mu x into a c cos mu y plus d sin mu y. Now, again let us put x equal to 0. When we put x equal to 0, we get u0 by equal to a plus b into c cos mu y plus d sin mu y. Okay. This is 0 for all y. Okay. So, either a plus b equal to 0, either a plus b equal to 0 or c must equal to d must be 0. Okay. C equal to d equal to 0 gives uxy equal to 0, this gives uxy equal to 0 for all x and y. So, not possible. So, a plus b is equal to 0. Okay. A plus b is equal to 0. Now, let us use the other condition u pi y is equal to 0 is equal to a e to the power mu pi plus b e to the power minus mu pi into c cos mu y plus d sin mu y. So, what happens? Either a e to the power mu pi plus b e to the power minus mu pi is 0 or c equal to d equal to 0. C equal to d equal to 0 makes uxy equal to 0. So, c equal to d equal to 0 is not possible. So, we have a e to the power mu pi plus b e to the power minus mu pi equal to 0. Now, from this equation b is equal to minus a. So, I can write it as a times e to the power mu pi minus e to the power minus mu pi equal to 0. Now, what happens? Either a is equal to 0 or e to the power mu pi minus e to the power minus mu pi equal to 0. If a is equal to 0, then what will happen? We have b equal to 0, a equal to 0 means b equal to 0 and a equal to 0, b equal to 0 will make uxy equal to 0, which is not possible. So, the other possibility is e to the power mu pi minus e to the power minus mu pi equal to 0 and which makes it u to the power mu pi equal to e to the power minus mu pi, or we can say e to the power 2 mu pi equal to 1, which gives mu equal to 0. And mu equal to 0 case we have already seen, mu equal to 0 means k equal to 0. K equal to 0 case we have already discussed, it is not possible. So, here if e to the power mu pi equal to e to the power minus mu pi, then we get the case k equal to 0, which is not possible. So, this gives you a equal to 0, and a equal to 0 gives b equal to 0. So, we get u x y equal to 0. So, this k greater than 0 is also not possible. Let us go to the third case. In the third case, we have case 3. Let us say k equal to minus mu square. When k is minus mu square, u x y is equal to a times cos mu x plus b times sin mu x into c e to the power mu y plus d e to the power minus mu y. Now, u 0 y, let us put 0, x equal to 0, u 0 y equal to 0 gives you a into 1, and then this terms become 0, then c e to the power mu y plus d e to the power minus mu y. So, this is 0 means either a is 0 or c equal to d equal to 0. C equal to d equal to 0 is not possible. So, a is equal to 0. So, this gives you a equal to 0, then u pi y equal to 0. Let us use this one. So, this gives you a term is already 0. So, we have b sin mu pi into c e to the power mu y plus d e to the power minus mu y. Now, this is 0 means either b is 0, b equal to 0 gives you a equal to 0, b equal to 0 gives you u x y equal to 0. So, b equal to 0 not possible. Okay. C e to the power mu y plus d e to the power minus mu y cannot be 0, because for that c and d both have to be zeros, and when c and d both are zeros, again u x y is 0. So, what will happen? Sin mu pi equal to 0, which gives you mu equal to n, and n taking values 0, plus minus 1, plus minus 2, and so on. Now, here if your n is equal to 0, mu equal to 0, mu equal to 0 means k equal to 0, k equal to 0 is not possible. So, n equal to 0 cannot be taken. When n is taking negative values, then what will happen? We know that sin minus theta is equal to minus sin theta. So, taking negative values of n will only add a negative sign to the expression, and negative sign will be absorbed in the constant appearing here, and therefore, we can only take the positive values of n. So, we will take mu equal to n, where n is equal to 1, 2, 3 and so on. Okay. And then what will happen? So, we will have mu equal to n, and then this will be u x y equal to we had a equal to 0. So, u x y is equal to a is equal to 0, b is equal to b will be absorbed inside there, and we will get u x y equal to sin n x, mu is equal to n x, mu is equal to n, and then b c will become some constant, say E n, then E n e to the power minus e to the power mu y plus d n e to the power minus mu is equal to n. Okay. So, we will have this sin n x times E n e to the power n y plus d n e to the power minus n y. Now, we have to see there are two constants E n and this thing E n and f n's. Let us put it as f n's. Okay. E n and f n, let us see that as y goes to infinity, u x y goes to 0, u x y goes to 0 as y goes to infinity. So, this condition means that the E n's must be zeros. Okay. Otherwise, the solution will not remain finite. So, this means that E n will have to be 0. So, we will have u n x y, let me write it as u n x y. So, u n x y will be equal to sin n x into f n e to the power minus n y. Okay. Now, these are solutions of the Laplace equation for every value of n equal to 1, 2, 3 and so on, but we have to consider the initial condition that is given, and the initial condition no, we have to still get the condition, this condition we have. We have not still used the condition u x 0 equal to u naught. So, this condition has to be used. So, what we do is, for all the conditions to be for this condition to be used, we will need the general solution u x y equal to sigma n equal to 1 to infinity f n sin n y n f n sin n x into e to the power minus n y. Okay. Now, this is Fourier. So, let me put y equal to 0. When we put y equal to 0, u x 0 is equal to sigma n equal to 1 to infinity f n sin n x. U x 0 is given to be u naught. So, this is Fourier sine series for the function u naught. So, we will have f n equal to 2 over pi, half range Fourier sine series, it is 0 to pi, and we will have u naught sin n x dx. Okay. So, we can integrate this. So, 2 u naught is constant, this is minus cos n x divided by n. We have here pi, here 0. So, we get 2 u naught over n pi, and we get 1 minus cos n x. Okay, 0 to pi. So, what we get? 2 u naught over n pi 1 minus cos n pi. This is equal to, when n is even, this is 0, and it is equal to 4 u naught over n pi when n is odd, because cos n pi will be minus 1. So, 4 u naught over n pi we have, and therefore, the solution u x y will be equal to. So, we take here, when n takes even values, f n is 0, and when n takes odd values, f n becomes 4 u naught over n pi. So, u x y will be equal to, let me write n as 2 m minus 1. So, m equal to 1 to infinity f 2 m minus 1 and sin 2 m minus 1 into x e to the power minus 2 m minus 1 into y. Okay. And f 2 m minus 1 is equal to 4 u naught over 2 m minus 1 pi. So, summation m equal to 1 to infinity 4 u naught divided by 2 m minus 1 into pi, and then sin 2 m minus 1 x e to the power minus 2 m minus 1 into y. So, we get this solution. Okay. You can take m equal to 1, 2, 3 and so on, you get these solutions. Now, so Laplace equation in polar coordinates. While solving boundary value problems for partial differential equations, it is better to use coordinates with respect to which the boundary of the region under consideration has a simple representation. To deal with circular plates or circular membranes, the polar coordinates r theta will be appropriate. So, we have to transform the Laplacian del square u to polar coordinates. So, let us see the representation of del square u in the polar coordinates. Let me see we have the relationship between Cartesian and polar coordinates, x equal to r cos theta, y equal to r sin theta, and this gives you r square equal to x square plus y square, and theta equal to tan inverse y over x. So, this gives you 2r delta r y del x is equal to 2x, which and 2r delta r y delta y equal to 2y. This gives you delta r y delta x as x by r means cos theta, and this gives you delta r y delta y equal to y by r means sin theta, and here this gives you delta theta over delta x as 1 over 1 plus y over x whole square into minus y by x square. So, this is equal to minus y upon x square plus y square, and this is minus r sin theta over r square, so minus sin theta over r. And similarly del theta over delta y equal to 1 over 1 plus y over x whole square into 1 over x. So we get here x upon x square plus y square, which is r cos theta over r square, so we get cos theta over r. Let us now write the partial derivative of u with respect to x. So this is del over delta u over delta r into delta r by delta x, delta u by delta theta by delta x. I can put the value delta r by delta x is cos theta, so cos theta delta over u over delta r plus delta theta over delta x is minus sin theta over r, so minus sin theta over r delta u over delta theta. Similarly, delta u over delta y we can write, this is equal to delta u by delta r by delta y, delta u by delta theta over delta y. And I can write it as delta r by delta y is sin theta, so sin theta delta u by delta r, delta theta by delta y is cos theta by r, so cos theta by r delta u by delta theta. Now let us write delta square u by delta x square. We have to find this value of this. So delta square u by delta x square is equal to delta over delta x of delta u by delta x. Let us notice that delta u by delta x is cos theta delta u by delta r minus sin theta over r delta u by delta theta. So this gives the differential operator delta over delta x as cos theta delta over delta r minus sin theta over r delta over delta theta. Okay, so I can put it here. So cos theta delta over delta r minus sin theta over r delta over delta theta. Okay, applied to delta u by delta x, and delta u by delta x is cos theta delta u by delta r minus sin theta over r into delta u by delta theta. Okay, now let us apply cos theta delta over delta r to this. Okay, so what we get, cos theta delta over delta r of cos theta delta u by delta r minus sin theta over r delta u by delta theta. Okay, so cos theta delta over delta r we are applied to this, then we apply minus sin theta over r delta over delta theta to this expression, cos theta delta u by delta r minus sin theta over r delta u by delta theta. Okay, and let us see what we have. You see, this is equal to cos theta delta over delta r of cos theta. R and theta are independent, so delta over delta r of cos theta will be 0. So what we get, cos theta times delta r of delta u by delta r, that is urr. Okay, now we apply the delta over delta r to sin theta, which again r and theta are independent, so minus sin theta will, when we differentiate with respect to r, it will be 0. So we differentiate 1 over r, and 1 over r gives you minus 1 over r square, minus minus becomes plus. So we get cos theta into sin theta divided by r square into u theta, and then we apply to u theta. So minus sin theta cos theta by r into u theta. Okay, u theta r. We are differentiating u theta with respect to r. So u theta r and u r theta will be taken as same. We are assuming that second order partial derivatives are continuous. So this is the expression 1. Okay, and similarly we can find the other expression minus sin theta over r times when we differentiate with respect to theta. So derivative of cos theta is minus sin theta. So we get minus sin theta ur. Okay, then we have cos theta times u r theta, and then we get, so we have differentiated this term. Now we get we have multiplied cos theta, we have put here cos theta u r r, and then I have multiplied cos theta inside. So I think this cos theta has to be multiplied inside here, cos square theta it should be actually, है ना. Okay, so we have what, cos square theta u r r we have. Now here what we have differentiated cos theta, we got minus sin theta into u r, then we get cos theta into u r theta, then we differentiate this sin theta, what we get, minus cos theta over r. So minus cos theta over r, and we get u theta, and then 1 over r will be when differentiated with respect to theta will give 0. So we get minus sin theta over r, and we get u theta theta. Okay. So what terms we now have? Cos square theta u r r, okay, cos square theta u r r, sin theta cos theta over r square u theta, okay, and here we will get sin minus sin theta over r multiplied to minus cos theta over r, sin theta cos theta over r square u theta. So we get 2 sin theta cos theta over r square u theta. Okay. Here we get minus sin theta cos theta over r u r theta, and here what do we get? Minus sin theta over r cos theta u r theta. So minus sin theta cos theta over r u r theta. So we get minus 2 sin theta cos theta over r u r theta. Okay. Now what do we have? So we have combined this term and this term with the two terms here, this one and this one, okay, and we get sin square theta over r into u r theta into u r, okay, sin square theta over r into u r, and we also have one more term, sin square theta over r square u theta theta. Okay. So this is what we get as u x x. We can check it in the next slide. U x x equal to cos square theta u r r, cos square theta u r r, then we get 2 sin theta cos theta over r square into u theta. So 2 sin theta cos theta over r square into u theta, and then we get minus 2 sin theta cos theta over r u r theta. So we get minus 2 sin theta cos theta over r into u r theta, and then we get sin square theta over r u r. So we get that, and then we get sin square theta over r square u theta theta. So we get this. Now we go to u theta u y y. Okay. So we have u y we found to be equal to let us see, u y is equal to sin theta u r plus cos theta over r u theta. So here also we can find u y y equal to u del over del y of u y. Okay. Now this gives you the differential after del over del y as sin theta del over del r plus cos theta over r del over del theta. This is del over del y. Okay. So what we have, sin theta del over del r plus cos theta over r delta over delta theta applied to sin theta delta u by delta r, this value, okay, plus cos theta over r delta u by delta theta. We apply this first term to both the terms here. So we get sin theta delta over delta r of sin theta u r plus cos theta over r u theta, and then we apply the second term cos theta delta over delta theta to sin theta u r plus cos theta over r u theta. What we get? Sin theta, r and theta are independent, so derivative of sin theta with respect to r will be 0. So, we get sin theta u r r. Then we apply delta over delta r to cos theta, it is 0. We apply to 1 over r, we get minus cos theta over r square into u theta, and then we get cos theta over r into u r theta. Okay. When we apply here, we get cos theta, we get delta over delta theta of sin theta is cos theta u r, then we apply to u r, so sin theta u r theta, then we have here delta over delta theta of cos theta will be minus sin theta, so minus sin theta over r into u theta, then we have 1 over r, derivative 1 over r with respect to theta will be 0. So, we get cos theta over r into u theta theta. So, we can get here sin square theta u r r minus sin theta cos theta over r square u theta, then we have sin theta cos theta by r u r theta, and then we have cos square theta u r, then we get sin theta cos theta u r theta. We have missed 1 over r here, I think. Yes, sin theta delta over delta r cos theta over r, this cos theta over r we have missed. So, this cos theta over r we have missed. So, we get cos square theta over r u r, then sin theta cos theta over r u r theta, and then minus sin theta cos theta over r u r theta u theta. Okay. This one minus sin theta cos theta over r square u theta, and then cos square theta by r square u theta theta. Okay. So, what we get? Sin square theta u r r minus 2 sin theta cos theta by r square u theta, okay, this one and this one, and then this we take this and this. Okay. So, this one and this one. So, we get 2 sin theta cos theta by r u r theta. Okay. We get cos square theta by r u r, and then we get cos square theta by r square u theta theta. So, this is the value of u by y. Okay, let us check this. So, sin square theta u r r we have, cos square theta by r u r we have, okay, 2 sin theta cos theta by r u r theta we have, minus 2 cos theta sin theta by r square u theta we have, and we have cos square theta by r u r theta, cos square theta by r square, cos square theta by r square u theta theta. Okay, this one. So, now we add u x and u y y, and we can see easily that we get u r r plus 1 over r u r plus 1 over r square u theta theta. Thus, the Laplacian del square in polar coordinates is given by this expression. So, del square u is u r r plus 1 over r u r plus 1 over r square u theta theta equal to 0. Now, let us solve this equation by again separation of variable method. We are having 2 independent variables r and theta. So, let us take u r theta equal to r r into phi theta. When you use this equation u r r equal to r r into phi theta in this equation, what you get? Delta u by delta r equal to dr over dr into phi. Okay. And delta square u by delta r square then gives you d square r by dr square into phi. Okay. And when you find u r we have already got, u theta theta similarly will give you u theta will be your r into d phi over d theta, and u theta theta will be equal to r into d square phi over d theta square. So, let us substitute these values in this equation, and then what will happen, we will bring all functions of r on one side. So, we will have r square r double dash plus r dash over r equal to minus phi double dash over phi we will have. Now, this is a function of r, left hand side is a function of r only, this right hand side is a function of theta only. So, r and theta are independent variables. So, this is possible only when each is equal to a constant. Let us take the constant as k. So, we have r square r double dash plus r dash over r equal to minus phi double dash over phi equal to k. Now, it will lead us to two differential equations of second order. So, we will have r square r plus r e r minus k r equal to 0, phi theta theta plus k phi equal to 0. Now, this is Cauchy-Euler equation. In this, the standard method is that you replace the independent variable r by say e to the power z, then it transforms to a second order differential equation with constant coefficients. We get d square r over dz square minus k r equal to 0, and so it is a linear differential equation with constant coefficient, and the second equation is again a linear differential equation with constant coefficient. Now, here what we have m square minus, so what will happen, let us now take the various cases. K equal to 0, when k equal to 0, phi theta theta equal to 0. So, phi will be equal to c theta plus d. R z z equal to 0 will give you r equal to a z plus b, but z is equal to ln r. So, a ln r plus b you will have. So, u r theta equal to a ln r plus b into c theta plus d. When k equal to mu square, then what we will have, r z z minus mu square r equal to 0. So, it is a linear differential equation with constant coefficient. The auxiliary equation is m square minus mu square equal to 0. So, m equal to plus minus mu, and therefore, r will be equal to a e to the power mu z plus b e to the power minus mu z, but e to power z is equal to r. So, we have a times r to the power mu plus b times r to the power minus mu, and the other equation is phi theta theta minus plus mu square into phi equal to 0. So, here we have the auxiliary equation m square plus mu square equal to 0. So, m equal to plus minus I mu. So, the phi is equal to a cos mu theta plus b sin mu theta, because we have complex roots. So, we have no, a we have already taken. So, let me write them as c and d, c and d. Okay. So, phi equal to c cos mu theta plus d sin mu theta. So, this is the solution in the case q k greater than 0. Now, we take the case k less than 0 when k is equal to minus mu square. So, when k is equal to minus mu square, r z z plus mu square r equal to 0 we will get, and therefore, the auxiliary equation will have two complex roots plus minus I mu. So, r will be equal to a cos z plus b sin z, and this will give you a cos ln r plus b sin ln r, because z is ln r, and phi double dash plus k is equal to minus mu square. Okay. So, k equal to minus mu square means we will get minus mu square phi equal to 0. So, we phi double dash minus mu square phi equal to 0. So, this time here we will get real roots m equal to plus minus mu, and therefore, phi will be c cos mu theta plus d sin mu theta. Okay. So, we will get this solution. Sorry, this will be plus minus mu. So, they are real roots. So, they are not complex. So, we will get c times e to the power mu theta plus d times e to the power minus mu theta. Okay. Now, let us take the case of a physical problem. The diameter of a semicircular plate of radius a is at 0 degree, and the temperature at the semicircular boundary is T degree. Find the steady state temperature in the plate, considering the center of the semicircular plate as the pole. So, let us draw the figure. Let us draw this figure. This semicircular plate, this pole, okay, is taken at the as the center of the semicircular plate. Initial line is this bounding diameter. This is bounding diameter, this initial line. So, here this is pole. Okay. Pole means r equal to 0, here theta equal to 0, here theta equal to pi. Bounding diameter is taken and the radius is taken as r. Okay. So, radius is taken as a, because we are given the radius as a. Okay. And the temperature at the boundary is T degree centigrade, while at the bounding diameter it is 0 degree centigrade. Okay. So, we have to solve this equation u r r plus 1 by r u r 1 by r square u theta theta equal to 0. Now, let us see what are the boundary conditions. U r theta, when theta is equal to 0, okay, we have temperature 0. Then when theta is equal to pi, we again have temperature 0, okay, here. And then u a theta equal to t degree, where theta is greater than 0 but less than pi. So, we have the boundary conditions u r 0 equal to 0, u r pi equal to 0, u a theta equal to t. Okay. Let us go to okay, yeah. So, and let us go to these boundary conditions u r 0 equal to 0, u r pi equal to 0, u a theta equal to t. Now, let us solve this equation. So, we consider the case k equal to 0. So, when consider k equal to 0, we go to the solution for k equal to 0. K equal to 0, the solution is u r theta equal to a ln r plus b into c theta plus d. Okay. So, let us write u r theta equal to a ln r plus b into c theta plus d. Okay. Put theta equal to 0. So, what do we get? U r 0 equal to 0, which implies that d equal to 0. Okay. Then what will happen? U r theta will become a ln r plus b into c theta. So, a c can times ln r plus b c times theta. Okay. Now, we are given that when theta is pi, okay, theta is pi, again u r theta is 0, okay, theta. So, u r pi equal to a c ln r plus b c ln b c into pi. Okay. U r pi equal to 0. So, this implies that a c equal to 0 and b c equal to 0, which means that u r theta equal to 0. So, this gives you because either c equal to 0, d is already 0. So, c will, if c is 0, the solution will be 0. If c is not 0, then a and b, okay, then a and b both will be 0. So, we will have again the 0 solution, and therefore, this is an interesting case. So, let us consider case k greater than 0. In this case, what we have k equal to mu square, and k equal to mu square, when we have the solution as a r e to the power a r to the power mu, we have u r theta equal to a r to the power mu, b r to the power minus mu, and then c cos theta, c cos mu theta plus d sin mu theta. Okay. Now, here what happens when r is theta is equal to 0, okay, we have u r 0 equal to 0. So, 0 equal to a r to the power mu plus b r to the power minus mu, okay, into theta is 0 means what? This is c, okay, this is 0. So, this implies c equal to 0 or a equal to b equal to 0. Okay. If c is equal to 0, okay, then what will happen? We will have u r theta equal to a r to the power mu plus b r to the power minus mu into d sin mu theta, okay, d sin mu theta we will have. And what we will have here, okay. So, what we will have here, when c is equal to, okay, now what will happen when theta is equal to pi, okay, u r pi, we have a r to the power mu plus b r to the power minus mu into d sin mu pi, okay. If either sin mu pi is 0 or d is 0 or a equal to b equal to 0, a equal to b equal to 0 is not possible because u r theta will be 0. So, either d is 0 or sin mu pi is 0. If d is equal to 0, then we get what will happen, c is equal to 0, okay, and d equal to 0. So, u r theta will be equal to 0, okay. Hence, sin mu pi must be 0, okay. So, sin mu pi is equal to 0 means we will have here mu pi equal to n pi, okay, or mu equal to n. So, n takes value 0 plus minus 1 plus minus 2 and so on, okay. So, when n is equal to 0, k equal to 0, okay, k equal to 0 is not possible, right. So, because k equal to 0 we have already considered. When n is equal to negative integer, then sin minus theta is minus sin theta, so minus will be absorbed in the arbitrary constants here. So, we can take n to be positive values. So, then mu equal to n and n takes values 1, 2, 3 and so on. Now, okay. So, we have found this, and d can be merged inside the constants a and b. We can write now u r theta equal to a, d can be merged in a, and we can write new constants, say e r to the power mu plus b r to the power minus mu times sin mu theta, okay. Now, let us look at this when r is equal to 0. R is equal to 0 means pole. At pole lies on the initial line. On the initial line, the temperature is 0. So, u is 0 when r is equal to 0. So, if r is equal to 0, this r to the power minus mu will make it infinite. So, what will happen for the temperature to remain finite at r equal to 0, we shall take b equal to 0. So, since u is equal to 0 at r is equal to 0, we have to consider we take b equal to 0, and hence u r theta will be equal to e. Now, let us replace mu by n. When we replace mu by n, for each value of n we will get a constant e. So, we will write u n r theta equal to e n r to the power n sin n theta, okay. And we have to one more condition is there, which is that at r equal to a, that is the semicircular boundary, the temperature is T degree. So, for that we need to consider u n r theta as sigma n equal to 1 to infinity e n r to the power n sin n theta. Now, take theta take r is equal to a. So, u n this will be now u, okay. So, u r theta, u r is equal to a. So, u a theta will be equal to sigma n equal to 1 to infinity e n a raised to the power n r is equal to a sin n theta. Now, u a theta is equal to t, okay. This is half range Fourier sine series. So, e n a to the power n, okay, can be now determined. This is 2 over pi 0 to pi, okay, t sin n theta d theta, okay. So, this is 2 over pi 2 t over pi, t is constant, minus cos n theta divided by n 0 to pi, and we get 2 t over pi n pi, okay, 1 minus cos n pi, and cos n pi is equal to 1 when n is even. So, this will be equal to 0 n when n is even, and this will be 4 t over n pi if n is odd, because 1 minus cos n pi will become double, okay. So, we will have E n, okay, En a to the power n equal to 2t over 0 when n is even, and 4t over n pi when n is odd. And therefore, the Fourier series, so u r theta. Okay. So, now what is u r theta? U r theta is equal to summation n is equal to 1 to infinity E n r to the power n sin n theta. Okay. The value of E n is what? E n is equal to this. Okay. So, we can put the value of E n now. So, we will get E n as, and n has to be taken odd. Okay. So, m equal to 1 to infinity e 2 m minus 1 r to the power 2 m minus 1 sin 2 m minus 1 theta. Okay. And this is summation m equal to 1 to infinity e 2 m minus 1, e 2 m minus 1 from here, e 2 m minus 1 will be equal to 4t upon 2 m minus 1 into pi, and then a to the power 2 m minus 1. Okay. So, we can write that. So, this is e 4t over 2 m minus 1 into pi and r over a to the power 2 m minus 1 sin 2 m minus 1 theta, and that is nothing but this 4t over pi. I can write summation n equal to 1 to infinity 1 over 2 n minus 1, this is 1 over 2 n minus 1, 1 over 2 n minus 1 r over a to the power 2 n minus 1 sin 2 n minus 1 theta. Okay. Now, this case k equal to minus mu square, this k equal to minus mu square can be seen, it is not possible. Okay. Because what we have u r 0 equal to 0 when theta is equal to 0. Okay. So, what do we have? U r 0 is equal to 0. This means that c plus d is 0, r a equal to b equal to 0, a equal to b equal to 0 will make u r theta equal to 0. So, we have to take c plus d equal to 0. Okay. And when u r pi equal to 0, similarly we will have a cos ln mu ln r plus b sin mu ln r, c e to the power mu pi plus d e to the power minus mu pi, and then what will happen, this a and b cannot be 0 again. So, c e to the power mu pi plus d e to the power mu pi will have to be taken 0. Okay. So, that will make it c, you put d equal to minus c. So, we get c minus d c times e to the power mu pi minus e to the power minus mu pi equal to 0. Okay. So, if c is 0, d is 0. Okay. If c is not 0, then e to the power mu pi will be equal to e to the power minus mu pi, which means that e to the power 2 mu pi equal to 1, which will mean that mu equal to 0. Mu equal to 0 will make it k equal to 0, which we have already discussed. Okay. So, c has to be 0, and c has to be 0 will give you d equal to 0. So, this case is not possible. Okay. So, we have the case k equal to mu square, which gives us the solution. Okay. So, with that I would like to end my lecture. Thank you very much for your attention.